This is the video titled Champlain Towers Collapse Discussion Column Offset and Their Inherent Weakness Based on Building Code. This is the triangle array video. I posted this on March 30th, 2022. Got a total of 9 views. Isn't that awesome? I talked about this. Now, I also posted in another private channel I have on YouTube that I don't... Now you guys seen this one. I have other private channels too. But the I posted this one, and it says 1 month ago someone commented. Neil Skoda. Interesting. Never noticed the offset when watching other presentations. No symmetry, just warped, loaded / tensions. Okay. It's got a total of 48 views, so some people found this video. Interesting that they found it. 48 people did. It's not that many people that I was showing it to. But this is at the 105 mark. I want to show you the where I talk about right here, where I talk about hinged, not failed column shear heads. So right about here is where I'm saying it rotated over, and there's the crack. And remember, this was posted March 30th. I think I might have posted this one even before that. This says 1 month ago they replied, so this is way before the release photographs that I'm right here, and I'm talking about the points that the fracture line, etc. I told you guys I did a video on this, but I didn't realize I shared it with someone privately. And over here also there's a fracture plane, a secondary. I'll share with you now that see this fracture right here? See it? If I can move the red line over, you would see it. It shows that there's another break there. So this was actually cantilevered over. When this fractured down, it snatched the last bit and pulled it away from the construction joint. Doing that, the cantilever action, before it failed, it created this break and then went down. And I see that symmetry on it. That's kind of very important too, to discuss the butterfly action. Let's see. I'd say to play this for the next 1 minute or 20 seconds. Let's see. Capacity using all the data I'm compiling for you now. Turn the mic up. Okay. Using triangle array and this fracture is. So you see me talking about triangle array here. That is indicator. Okay, little internet problem there apparently. Of what transpired during the collapse. Remember, the butterflies. Let's go back. And I said butterfly there. You heard that. Let's go back. See if I just reload it and get it more clean. And this fracture is triangle array I'm talking about. So it wasn't with you guys I shared it. Apparently, I shared it with another group I'm working with. K column, and you see there was a BMA here. It's down equally. It's not on an angle. They're parallel. I'll do another video explaining how the deck fails in that capacity using all the data I'm compiling. There we go. For you now, using triangle array, and this fracture is indicator of. Really? There we go again. Same what time. Transpired during the collapse. Remember, the butterflies identified by 2 people. The sun. All right, so my butterflies. What I talk about there. I think I tell you guys to go to 40 minutes. So here's me doing the drawing of that. I need a small thumbnail. You see it showing the offsets. I used 40 minutes even. It says. Let's go there. Wow, that was lucky. And so I used this box to identify the working triangular arrays. And I'm going to move it around, but you see there's the K, the one that has the fracture by it, and that's the one I'm going to talk about. Stands out so strongly. Remember, I talked about this in March, but I talked about it before this too. But I put together a video, finally shared it with other engineers I was trying to work out something with. Let's let this roll at 40 minutes up to 43, I think. It's close, like 20 by 19, I think, or 23 by 20. I don't know. It's pretty close to that. Pretty good, even two-way action. So that is the same, pretty much as that one. So you guys, to give you a quick background, because this is over an hour and 13. I know I get to rambling, and you guys don't want to hear my rambling. So this is just showing this equal box. I'm able to move it here, so you can now quickly snap of a finger, see that, okay, those are equal, pretty close to the dimensions. Here we go. So if you're going to pick on... So you see how it's equal to these columns right here when I dragged it down. a failure spot, we're like, well, these are kind of symmetrical.
I said, if you're going to pick on a failure spot, these are symmetrical. So maybe you wouldn't pick on that. And when I'm driving at it, you're going to pick on K. The one right there that I showed it just now with the red arrows on it. Remember, I posted this March 30th on Rumble. And then,
so the loading here would be pretty symmetrical.
So people on Rumble got to see it. 2 people did, actually. I'm sorry, 8, but 2 commented. But there's that fracture line there that I talked about it. And then this was the added bonus of this one. Let's go back to the video and let's work the next minute or so.
Where is it not symmetrical? Well, down here.
Down here it's not symmetrical. Remember I talked about in the last video that you guys are watching to talk about this offset. Right there is the cracked box, the planter box. And this is what I'm identifying for the group.
It's not symmetrical. Look at that. Take the same box, I put it over here, and now it's outside of it.
See, it's outside of it. This is the one I'm pointing on.
How about if I push it up here? Well,
yeah, well, that doesn't exist. Just so you know, it's the shape of the car is the loading, but this exists. So don't get confused. It existed only on these 3 corners. This next pickup point from here is way back here. It's from here, way back here, and from here laterally per our visual right here.
It kind of hits it transversely, diagonally rather, not in plane with it. So that's not how it counts. And so this is where, and that's that one again. And I can use the angle from here too. Also.
So you see, I'm picking on that. Well, here we go.
Rather, because this is where the crack goes across the deck.
Okay, remember I talk about the crack going across the deck, and I show it the red ink, and that's why I indicate that that's our loading. I also have another reason for there's an elevation change with this side of the crack and this side. I believe that's when that shear wall came down. It came to this side and drove this down. But there's another crack here that symbolizes that impact on this side.
About 50 degrees, so let's see. So it lines up with that just about. It goes something like that.
So what I'm saying is, if this was down here, roughly, it would be at that point there. Our crack is pretty close, following the crack path. Well, let's see if I change it again for a second.
So that's why I used this point. Don't worry about that, where that is. It's this point I'm using. And that gets me that 50 degrees. Let's look at this one.
So I talked about that 50 degrees with you, and the angle, the stresses are going, I shall reveal it. Go ahead, let me let it play. Just realize
this is where the car loads, that's why we're going to look at it. So this one is like this. And let's do that.
Just extending it for you.
So you can see where they don't really, it doesn't work, does it?
See, from there to there. See how they converge here? But down here, it's not converging. And it's this converging is just, stresses-wise, just ridiculous. So the rebar that's going across here it picks up over here where there's a column, being facetious. There is no column over there. The rebar is straight, keeps going continuously over. It's airballing everything up to the control joint. It's getting snatched from here. Oh, it's airballing here also, except for airball, like a basketball and you miss, it's airball. So this goes, the steel coming across here. Oh, they thought of it. They put a beam here where this loads onto. No, they didn't. They just want this steel that's coming this direction will load into the steel that's going that direction across the shear heads, the column heads. And so much for that. And so this concrete alone, this mid-span, has to take the mid-span of these guys also. Wow. To pick up the loading points, the loading points. Let's just do that.
Everything's being torqued and pulled out on this area here.
In fact, this one here, look at this. It converges away, non-converging lines. See it? This one goes away this way. And if I pull on this one, I should have put it up here for you, but they're not converging. This one's parallel to the back wall pretty much. It's only got 6 inches or so offset from that one. That's why I pulled it long like that to show, so the 6 inches would identify. So you can see what it looks like extrapolating further out. 6 inches per that footage. But it's right here. And that steel comes over from this bay over to here, from this column head over to here, and probably does clip pretty. It gets into the critical shear head of this column. I think 6 inches. I mean, it's like 12-inch column, 16-inch columns. I forget now which was what. But let's go.
The triangle array, as it's called, is screwed. I'm sorry, not triangle, rectangle array. It's screwed. It's terrible. It's terrible here. This loading here creates these torque action here.
So see what I said? A torque action here, and I point right at the crack. So I had no activity to that. I had no knowledge of this photograph existing. Let's back it up again 10 seconds. Let's hear me say right here.
Here, this loading here creates these torque action here.
But just move the mouse too quick.
Here, this loading here creates these torque action here.
I caught it then. And I just sit here, and I'm right here over our failed K. All right? I'm not going to bore you with the rest of the content because you know how I get. I get the yakking and, you know, it's some details and I go over. But this wasn't intended for the true public to capture. Over the other one's a different version, a little bit different over here. But this is the one I published. But I'm going to vanish this one also, so I'll delete this one. And because there's only 9 views there, and you know what, this Rumble thing, it's not working over here anyway. 9 views, I'm not going to waste my energy on that anymore. So that's no good. It's sort of no good. It was so I put it private over here. I put it public over here, and 9 views really. So that's a waste. I'm not going to waste my time with that. And I don't want you guys to get beat up with trying to find more nuggets out of here. There are no nuggets that I want to share besides this one. The other stuff is just me rambling. Look at this thumbnail. I'm sharing the wall system that collapsed. I'm talking about there's no reinforcement there. That's okay. Then I'm beating up the Miami Herald article again. And you've seen that already. Here I talk about the elevation changes of the deck, just so you know. Here I go over the other plans and I show the overlay that the columns are. It's a little different. The other plans have columns here doubling down by the car. It's not the same. They've got a different configuration. The structure comes all the way out to here pretty much, so there's another column there. It's not the same loading. So let's stay with, and that was a long detail here. And I got a couple of, I flipped the, okay, so there I'm talking about the triangle array. Look at the little thumbnail. I'm explaining it with how you can move it around, how it gets more torque as you move it. So you can visualize what I'm talking about there. And I bring it back down. Now I'm showing it's way off. That's K, is what I'm pointing at in that thumbnail. So let's do that. That's good. It's a good overlay. See the thumbnail above the mouse there? That would be the K one I'm pointing at in the screen you see in the background. That's what I'm trying to identify, is that this is the one. This is the lady. Let's do it again right here at the very end, and I'll terminate the video. Wish you guys all the love. Well, that didn't work.
It's screwed. It's terrible. It's terrible here. This loading here creates these torque action here.
Doop. That's what I'm talking about. So right there.
Here, this loading here creates these torque action here.
Yes. So the loading and this whole system creates a torque action here. And just imagine this is not there. But this is, so our spans again are from here to here, from here to here. All the anchor points is what I'm doing here, laterally, and then behind us. And these are pretty much in line, so it creates a better plane, if you will. This is where our butterfly is. Ending the video. Love you guys. Sorry about the mouth. Running my mouth at me. Bye.